Hello, in this video I'm going to explain the code for the first project called Virtual Makeup. So let's dive in the code. Here we have some libraries that we are going to use in the code. We also make use of the face blend command called as FPC that we use along the course provided by the teacher. Then we import the data path where we have the image of the girl that we are going to use. Then here we have several functions that are going to be used along the code. But first let's go to the main code. So the main code is here. Here we open the image of the girl. Here we load the model of the 68 face landmarks, and using DLF face detector, a rectangle is set around the face of the woman, and we use the predictor to estimate the points of the position of the 68 face landmarks. So we're going to detect the face making a rectangle, and also we're going to set the face landmarks using DLF's using DLF detector and predictor. Here we're going to select only the points of the lips and create a mask with the same size as the image and with white on lips area. So we're going to have a mask with white on the lips area. Then we're going to do a morphological operation close with rectangular kernel to improve the mask. This is the code. Here we're going to blur the mask using a Gaussian blur. Then we are going to have the inverse lip mask using a bitewise knot of the lips mask. Then we're going to change the lips color. Here I did a function called change part color where we take the image, the lips mask, and the inverse lips mask. This will also be used to change the color of the eyes. As we can see, here we have the change part color. Here we take the image and then we do a color mapping. I use the hot color map. Then we make conversion to float to do image operations. We do the float of image colored. We get also the float of mask and the inverse mask, and also the image we get as a float. Then we get the face without part and new part colored image. I put part because we're going to use this function for eyes and also for lips, so it's a part of the body. So face without part, and then we do multiply, inverse mask, and also the image. And the new part would be the multiplication of the mask with the colored image. And then we add the face without part and the new part to have the resulting image. Okay, and so at this point we have the lips colored. Then we're going to do the eye color changing. So for this, we also need to create a mask using the face landmarks of the eyes, well, of the left eye and then of the right eye. We create a mask using the function. I think I didn't explain the function, so it's here. Create mask. So it only makes eye mask with zeros, like the original image. Then we do fill convex poly to have the eye mask, and we take the landmarks that we pass to the function and we put one in the 255 for the part that we are interested in, which could be defined by the landmarks. And then we convert the eye mask to an integer of using NP, using numpy, and then we return the mask. So after creating the left eye mask and right eye mask, we're going to find the iris of the eye, and we are going to use the previous mask that we found. We're going to pass also a threshold. This is by testing. So we pass the left eye mask, the image, and a threshold. Let's see what does the find iris function. So here we have the find iris. We're going to use the red channel, and we're going to do the binary inverse thresholding of the red channel image. As you can see here, we use the threshold that we pass, which is 40 for our case. Here we're going to do the kernel. We're going to create a kernel, and we're going to do a morphological delayed operation using the kernel and the binary image previously thresholded. We're going to do merging operation, and then we're going to convert the morph image into float to do multiplication of the mask and the morph image. And here we're going to return the iris of the face. Okay, then here we have the iris. Yes, here we have the left iris and the right iris. And then we're going to get the centroid of both iris. For that we have a function called find centroid. Here we have the function find centroid, which uses the moments of the area and return us the position of the x and y centroids. Okay, then we're going to generate the iris mask and its inverse mask. So for this, this function is going to return us the left iris mask and the left inverse iris mask. And let's see what does the create iris mask do. It needs the left iris and also the left iris centroid. Let's see this function, create iris mask. So it's here, create iris mask. We receive the iris and the centroid. We find the counters of the iris image. We put a big counter, so that so that the first counter detected will pass when we are doing this condition. But let's see, we're going to loop through all the counters found in the iris, establishing a minimum enclosing circle. So in this, we're going to do enclosing circle. We're going to use the function cv2.minEnclosingCircle, and this will return us the center of the circle and the radius of that circle. And we're going to use that data to evaluate the distance of circle's center to the iris centroid. Here we have that evaluation. We do the rest of the centroid minus the x coordinate of the centroid, and also the y coordinate of the centroid minus the y coordinate of the mean enclosing circle. Then we're going to do this comparison, and we're going to, at the end of this loop, we're going to take the center and radius of the mean enclosing circle with the smallest distance from iris centroid to circle's center. Okay, and we're going to get the center with the x and y coordinates, and also the radius, which was done by the mean enclosing circle. This is going to be the data for the iris of the eye. Okay, then we're going to create a mask with the same size as the iris image, and its opposite would be the inverse mask. So here we create the mask with zeros, and we create an inverse mask with ones, and we do the circle with the data that we have previously from the meaning closing circle. And here we do also the inverse, but with zeros. The mask is done with ones in the interested area, and the inverse is done with zeros in the interested area. Okay, then we're going to do a mask blurring to have better blending when we do the operations. Okay, so we use the Gaussian blur, and also done in the inverse iris mask Gaussian blurring, and we return the iris mask and the inverse iris mask. And here we convert the as we have previously with the ellipse colored, we have the result, the image result, which was a flat image. So we converted to integer, and we use this function float64 to uint8 to do the color mapping. Okay, and we convert here. So we use the image that we converted to uint, and we use the function change part color. Let's see what does this function do. Okay, here we have change part color. We are going to do the color mapping on the entire image to paint the interested part, lips or eyes. Yes, so here we have I'm image colored, CV2 apply color map, and I'm using the hot color map. So I think this was the same as the lips coloring, so I already explained. I'm not gonna go through all this again. So, but it is the same as we did with the lips. And then we do at the end we pass their left iris mask, and we will have the right and left iris and also the lips colored. So that's it. In this part I'm only showing the results of the girl, and we are going to have this exit image. So project complete.